Hey folks, I'm Akshay. I'm the CTO and co-founder of a company called Bifrost, and actually, the company's name is Maxim. Um, we, we started with a product called Maxim. Maxim is the evaluation and observability platform for GenAI developers. The whole idea was when multiple models were releasing, the biggest problem with building AI workflows was which model to pick up for what. Essentially, you need to have a so there are multiple problems when you pick up a model, like what's the latency, what's the accuracy, in which cases it's working, what are the prompts, how to tune the prompts. We started with that. We realized over the period of time was when number of models were increasing, the one core problem we faced was how to route them to different providers. And we tried a bunch of gateways from the market. One of the things common with all of those gateways was they were built in a stack which are not built for infrastructure. So if you see, LLM is one of the most prominently used gateway, was built in Python. So at scale, it was just breaking at every level. So I've been a Go fan for really long. I've been writing Go since 0.7, 0.8. So I was pretty sure that if we pick up Go and we kind of build gateway in that, it's going to be much better than how any of the gateways are performing in the market. And that's what we did. We did it for a year. It was working really well for us, and we started getting similar problems from our customers who are our Maxim customers. Then we realized, okay, it's better to kind of just contribute to the community. So we open sourced Bifrost in August, and the feedback was phenomenal. And that's where we realized that, okay, this is a bigger problem to solve. We started like a complete team focusing on gateway. Team as in like we started with 2 people, then 3, then 4, and now we are 6, 7 people working on Bifrost, and we are continuously growing from the engineering front. We are now around 11. But what we do at Bifrost is the fastest from the latency perspective, but we do a lot of intelligent stuff around it. And one of the important intelligent stuff that we do and that I'm going to talk about is the adaptive load balancing. And just to give you a gist of adaptive load balancing, this is what it does. So this is the dashboard. I'll just quickly walk you through what I'm going to show you and how it's going to look like. So let me see. So these are like a couple of agents that I'm running. We have like a product called Bifrost Edge, which automatically picks up all the AI traffic that is routing through it. And what it does automatically is that whenever you're hitting a model, the adaptive load balancer always figuring out what all Bifrost nodes we have, what all providers we have, and how to pick which key. And it does it on 3 different levels. One is what are the latencies that we are seeing, and latency is a very tricky metric when it comes to AI gateways or like AI traffic. The second we look at is what are the error rates, and error rates also very tricky. Like 429 is not as bad as, let's say, 401 or 500. These are very different. You have to treat them very differently, specifically in the AI traffic. And the last but not the least is the utilization, like how much traffic we are utilizing in one of these paths. So
does it do a failover as well in case?
Yes. Yeah, it does. It basically we have options. So basically, I was just setting up this is a new instance. I was setting up the multiple providers so that, let's say, OpenAI is configured on on Vertex as well, or like Anthropic is configured on Bedrock as well, and then we pick up compare these 2 models.
But to the end user, it doesn't come up.
Never. You never know. I don't even know what model is being used when I'm using this, by the way. It automatically picks up what it has to do. So, going back to the presentation. This is what I'm going to talk about is the adaptive load balancer. So whenever a question of every AI request that comes to us, at least, because there are 2 types of loads we support with Bifrost. One is you have an external agent which your users use, and that traffic goes through us. The second one is your internal users are using Cloud Code a lot, and that request comes to us. And in both cases, one of the important aspects we have is which provider should serve. So for example, if you use a lot of OpenAI stuff like GPT-4o or like GPT-5, GPT-5.5, you have multiple options. You have OpenAI, you have Azure, you have now AWS, Vertex. Which of these are performing better? And performance is a very relative metric, and I'll talk about that more, but that's one, like which provider serve this model. And again, each keys also have some kind of restrictions, right? For example, some keys you may have a lot of reservations on the PTU side. Some keys are like kind of erroring out quite faster. So the decision has to be taken in real time on these 2 factors. And one of the biggest problems here is that when you are playing with these factors, they have to be real time in the sense that you cannot have that this model or this provider was performing better an hour back, so it's going to perform better now. There has to be a lot of recency bias, and also the patterns that you have to figure out over the period of time. Like that's what I was talking to before the talk, right? There are patterns. For example, whenever US starts, you would see a lot of latency spikes on OpenAI. It's pretty natural. The moment US gets up, like a lot of traffic comes, a lot of models get overwhelmed, and you would see like a pattern going different. I mean, we see that every day whenever the US time starts. And these are the patterns which are extremely critical. So whatever control loop we write, you have to be extremely real time. And real time is still again become relative. We do every 5 second loop across all the nodes and figure out how traffic is behaving across different models and different providers, and we recompute the weight. So what I was showing here, one second. Okay, what am I? Why am I not able to? One second.
Can you unmute yourself on the call?
Oh, unmute. Okay, I thought that it'll just come back again. So what I was showing, the dashboard that I was showing you right now, you could see that we have some weights on everything. So for example, these are the scoring factors, which is like error, latency, and latency impact.
Akshay, it might be not visible for people in the back. Is it?
Oh, is it?
Yeah.
No, it's not visible?
Increase the font.
Yeah, I'll do that.
Just get rid of that floating window.
Yeah. Is it better?
Yeah.
Okay, perfect. So what I was talking about is that whenever the traffic starts routing, right, we essentially have like some computes of how it's performing across different, and we consider three factors around it. One factor is the errors that we are seeing, latencies that we are seeing, and then there's a utilization impact on it. And I'll explain these three factors and how we compute, but this happens real time. So you would see that how many attempts we have done, how many successful attempts have been there, and then accordingly what we have basically computed weights for each of these model plus providers. So technically, now whenever request will come for, let's say, GPT 5.5, we have these two keys, and we know that, okay, which key has to be performed because it's just 4 attempts right now. So we'll try to use it a lot just to see that if it's performing better versus other key. Now going back to a bit of math of it, let me start it again. Okay, so this control loop that I was talking about, this control loop of computing weights according to the performance happens like every 5 seconds and gets distributed across all of our nodes. And these are the patterns that we were talking about, like how each route earns a weight. A weight is computed. Error has a highest impact because the moment error happens, doesn't matter if other key is slow or not, we have to actually, the whole aim is to make sure that there is 100% success rate for our end users. So if at all a key or a combination is giving you higher error rates, we start penalizing it extremely fast, so it goes out of the loop, and other keys start getting used a lot. The second one is latency. If we have two different keys and providers, and if we see that one is higher latency, one is lower latency, then we pick up the better latency kind of combination. And the last one is utilization. Utilization is basically starvation control. If let's say we figure out that this particular path is working the best, we should not use it. Should not overuse it. So the moment a particular path gets used a lot, we start giving it a utilization penalty, and then starvation control goes out of the picture, and we start trying out everything else that is available. This is a math. I mean, it's pretty simple. It just looks complex. It's not complex. What we try to do overall is that we have a weights to every factor. So as I talked about, it's error, it's latency, and then it's utilization, and each of them get some weight. So for example, in this example, I've given 0.5% weight to errors, 0.35 to latency, and 0.05 to the utilization. The utilization should be like, it's okay. I mean, if you utilize something and it's working, perfectly fine. What we try to do is that we actually keep on shifting these weights based on the learning, because, for example, we have, let's say, two customers. One customer has a really good reservation with Azure, and one customer has really good reservation with Vertex. In their case, irrespective of what happens, Azure is going to perform the best and Vertex is going to perform the best. We learn from that and we keep on switching these factors automatically. So every time, every every 5 seconds when we realize that okay, certain providers are performing better irrespective of whatever traffic we are sending, we just keep on changing the weights and we make sure that utilization has absolute zero impact because it's just working all the time. The latency curve, which I'm going to talk about, basically it's a very, whenever it comes to AI traffic, the latency is a very, very different thing. One, let's say you have two requests. One request took exactly same message, but one request took 10 seconds, one request took 2 seconds. It does not mean that the model 2 is better than model 1 because you have to look at 2 or 3 things more than just latency. One, whether there was reasoning involved or not. And reasoning is very critical because reasoning will improve your accuracy. So if reasoning is involved and the latency is higher, that does not mean that it's lower, like lower latency model is performing better. It's just they are different models, so they cannot be compared together. That's why our computes are based on combination of provider plus model. We do not go across the models because if a reasoning model is taking more time, there's a reason why it's taking more time. It's thinking a lot and then giving you the answer. The second piece is we actually have a tolerance band. So what happens is, and we continuously predict also, by the way. So essentially, this is what we are seeing. This is the middle of the band, and this is the max limit that we allow to play within. So if let's say latency play within this band, we do not really care about. We do not change anything. We do not learn from anything because it's pure network jitter. Model is like for a bit it was kind of overwhelmed, and that's why we do not change anything. The moment anomaly happens, we start kind of recalibrating that. Okay, if something is going wrong for really long, we start kind of shifting the weights. What I was talking about here, we start shifting the weights of the error. And the last piece is we continuously predict what should happen next because we have seen every 5 seconds we compute that how the pattern has been of the latencies, and then we start predicting okay, it's gonna be higher or lower, and accordingly we kind of shift weight, which is the recalibration band. We just keep on shifting the weights of each of the provider. Again, the model is same. It's a logarithmic model because whenever we try to figure out the slope, we have to actually add the alpha and beta together, and then the if is basically a factor we try to kind of, it's a constant that we keep. Again, it's a randomly picked up constant for the clamp. Clamp is basically, very basic example is that let's say this graph is for latency. Whenever latency changes within this band, how much we want to react to it. For example, let's say same model, same provider, latency was 1 second, and then latency became 1.5 seconds. Do we entirely stop sending traffic? Do we say that okay, it's okay, 1.5 is okay for now, we should just go ahead with that? Actually, it's defined by this clamp, and this constant, again, it's pretty biased, or like we are just pulling that constant out of thin air. We are looking like we start with 1, we started with 1.5, right now it's 2, because we want to kind of make sure that if there is a latency impact on any of the path, we just want to react faster. So, I mean, forget all of this math. The way it does is that it actually has a time with latency graph, and it actually computes a band, and then within this band we do not react at all. After that band we start reacting a lot, like penalty gets applied the moment any metric goes out of this band.
Okay, Akshay, can I ask you?
Absolutely.
So 2 questions actually. So one, I think latency.
About this? Oh, okay.
Latency part.
Okay.
I think there piece which you touched already on is the mode of the model, which is the model type, and then whether it's
Correct.
thinking and hard. Currently it's like hard extra and all that stuff.
Correct.
Which also comes with it. And I also obviously saw there's a token that's multiplication, I guess.
Correct. So we go to the per token latency, not the, because let's say a request is responding 100 tokens, another request is responding 1000 tokens. You can't compare the latency because it's
correct.
Processing more tokens.
Exactly, because I think that plays a very important role.
Correct.
It's like how much is input token, which might define how much
Correct.
longer it's going to take the processing.
Correct.
In general. One question which I have is, this is a within prompt side of it actually, is in the prompt you can, even though with the less token, you can define multiple rules, right? So
could you like what do you mean by
so
that?
for example, I can define, hey, do X,
Mm-hmm.
1, B, avoid void,
Mm-hmm.
Y, and C, do Z.
Mm-hmm.
Something on those lines. Those are 3 rules.
Mm-hmm.
Versus a token which has a lot more strings in it.
Mm-hmm.
But this token here, which I just gave 3 rules, might take longer because it requires much more
Fair
processing
enough.
versus the other one not. So does the rule within the tokens or within the prompt plays any kind of role in latency calculation, or does it?
We don't care. We don't care. What we care about is that whenever we compute a latency, we just look at the combination of the tokens. That's it. So and that's why reasoning also matters a lot.
Right.
So what we look at whenever we are looking at tokens, what kind of tokens they are. Like for example, it's cache tokens. They're going to be extremely fast because they are coming from the cache, right? Exactly. So each of these tokens have different weights.
Right.
So when we see the response, we actually have all of this data. Like we have cache tokens, we have reasoning tokens, we have normal response.
Also the tokens.
Of course. Yeah, that's why latency is extremely tough part to figure out. You cannot apply your traditional knowledge of latency to it at all. It plays very different when it comes to AI traffic. You have to essentially understand one, number of tokens, second, type of tokens, like which tokens actually work.
Because I was about to put
Absolutely.
the type of the token.
Absolutely, yeah. Type of the token is extremely critical.
And I forgot my second question.
Happens to all of us. Perfect. So again, it goes back to the same thing. How each of there is no linearity whenever we assign a weight to a model. By the way, so we actually have the weight assignment based on all of these all of the three factors that I talked about. We assign weight out of 0 to 1,000. 1,000 does not mean that it gets 100% of the traffic. It basically gets some amount of 78%, for example, here. It again changes based on the patterns, by the way. We do not really have standard numbers for each of these, but like based on how your traffic is routing, how each of the providers performing, you would see the switches, but it's never linear. It's basically exponential. If a model is performing or a combination is performing better, it will have exponentially higher traffic versus other cases. And that's how it shifts basically if it's healthy, whenever we see error and slow, it goes to the degraded. If we go error more than 5%, we go to failed. And then the moment after 30 seconds, we can give it a cooldown. Because whenever it goes from degraded to failed, we actually quarantine the entire path completely. And then after 30 seconds, we try out a few things. If we see that, okay, the request is going well, then only we bring it back. Otherwise, it just goes back again in the degraded and failed state continuously.
Do you load balance turns or a whole request?
It depends on the kind of requests that are coming. So for example, in a lot of our customers' cases, you need a session also. Like just to give you an example, OpenAI, if you use Codex, right now I'm using Codex, right? Codex uses a WebSocket. So even every turn, they do not send all the turns all the time anymore. They actually have a session maintained on the server side. In that case, we don't load balance because your session will be messed up completely. Your responses are going to be wrong. On top of it, we also have a header that users can set up that, okay, this is the session ID. In that session ID, we don't load balance unless that model is completely down. We just keep the same path. So it depends on what kind of traffic we are serving, we do the session management.
So you detect that, or you have a configure application?
Both ways. If users wants to enforce, they can put the header. We also detect that, depending on the traffic, because we have the headers, right? Every, let's say you're using Cloud Code or Codex, they send a session ID with it. So we detect that this is a session ID. This was the last path we had picked up, and then we just send it traffic to the same path.
So those headers have this kind of a thing that.
Yeah, they have a session ID. They have a session ID. So session ID is a very standard term on all the CLIs or the desktop apps. So we understand that and we send it.
So will that this adaptive load balancer work for on-premise deployments where people are serving their own inference?
40% of our customers actually have VLLMs, and their 90% of traffic goes to in-house.
Where does this sit? Like,
It's again sit so basically
before VLLM or?
Before VLLM, yeah. We sit in front of VLLM. They have let's say technically they have 3 servers of VLLM, which are serving, let's say, Llama 3.1, 3.2 or something. Right now we know that this is the model. And we actually figure out between these three Llama 3.2 which one is performing better and adaptively load balance between them.
I have more questions, but I think
Absolutely. I'm happy to answer. Yeah.
So there are certain techniques after the VLLM where you can take advantage of like optimizations where the context is same, the agent is same, all that, right? But if the load balancer sits before VLLM, the private inference, I understand like Codex and other things. Anyway, I don't have control over the optimization after the VLLM, like even at the VLLM, right? I cannot add a plugin to VLLM. But when I am serving my own inference, I think I do have a preference to add plugins to VLLM and optimizations at CUDA or between VLLM and CUDA. I think those will affect. I'm not able
Why?
to visualize.
Why would that affect?
There is no configurability at load balancer that whether I will continue. It's only session you are saying.
No. That's why we have the headers. So it depends on what you want to do. We give you full control if you want to control that. If you want to say that we don't want load balance for this particular inference, you can also do that.
Okay.
The point
So
is,
this is optional.
yeah, based on the configuration. Like if you want to say that, there are two parts to it. Like what you're saying is that you have optimization in CUDA does not get impacted by load balancing. How requests coming to it does not matter. Once a request comes, then these optimizations kick in. So putting a load balancer in front of it has absolute zero impact on whatever optimizations you have at VLLM level. I don't see why that would get impacted. The only thing that obviously get impacted is that if we keep on switching between one session, that okay, first request went to VLLM 1, second request go to VLLM 2, even in that case, there are two things that usually people do because that's keep on happening with the internal inferences is that one of your deployment went down. So they actually have a memory layer outside the VLLM. So whenever a request is trying to go there, they actually put it from the memory layer and then put it inside the VLLM. So even you're using load balancing, and if you have a memory layer, it just works fine. Because that's the only component that gets impacted, which is the memory. Nothing else get impacted because we are not doing anything for the optimization. It will not. You remove Bifrost.
I understand, like you are not doing anything, but the routing of to the same model, same path makes a lot of difference.
That's what I said. The difference is memory, nothing else. The only difference is memory because you know the session. That usually is outside layer because even in normal deployments, your one of the node can go down. What would you do in that case? You need to have that memory outside because after memory, it's a stateless thing. Give a request, it gives you back the response, nothing else.
And when you're saying memory, you're talking KV cache. Like
Anything. I mean, KV is one of the ways.
yeah,
I mean,
that's mostly on the model side, but I mean, other things are model.
Yeah, correct. I mean, specifically like your last history, right?
Correct.
They keep somewhere in the vector store and keep on pulling the relevant one.
Different.
Yeah.
So that's a memory.
KV is for the specifically you're talking about the VLLM.
LLM.
Yeah.
Just maybe a question for all the audience, like who has worked with any AI gateways and like are you guys like following? If not, then
Yeah, I'm happy to go.
Would be useful to
Yeah.
just draw a parallel from a classic normal
Sure.
load balancer like Nginx that most of us have used probably to Bifrost. Like what parts of normal HTTP or a TCP traffic that are same or different from a LLM AI?
I'm happy to start with the
maybe
basics.
work from-
Yeah. Sorry, I think yeah.
So actually, how do you detect that the request is coming from the client?
Mm-hmm.
Is a reasoning request. Depending on the client tells the gateway that this request requires a reasoning model, or it is something that is an intelligence at your level.
No, nothing is intelligent or nothing is told by client. We actually look at the response. In the response, we know that there are reason because we get what kind of tokens are being responded with. So there are reasoning tokens. Whenever reasoning tokens come, we know that it's a reasoning request. And then accordingly, we load balance. It's reactive, it's not proactive. Our adaptive load balancing is proactive only in a scenario where we have some data. Otherwise, it's completely reactive.
And do you also consider token budgets within?
Yeah. Yeah, we do have that. So essentially, I mean, it's a full-fledged gateway, right? So we have budgets and everything. So the moment you're going closer to budget, we have fallbacks, all of these things placed in.
Okay, and from latency standpoint, do you consider NAD and latency, or how do you?
Yeah, we consider three buckets. So we have P50, everything matters, right, overall. But we have P50, P90, P95. We look at these three buckets. P95 has higher impact purely because we want like the distribution to be as normal as possible. P50 is a very useless metric, but still important metric, so we consider that as well.
Okay. So, for example, let's say within our application, we have multiple workflows, right? And we use different kinds of models for the target group, right? Some require higher model, some require lower model, right? For example, GPT-4 really is a lower model, but still its latency is very high compared to the GPT-5, GPT-4.
Because yeah, it's
Right?
the
So how do you decide in that case? How does it?
It's 11 o'clock.
We don't. That's what we stay away from. So the question is basically for everyone. The question is that there is GPT-4o which has higher latency and there is GPT-5 which has lower latency. How do we handle these scenarios? So as a gateway, the first rule of thumb for us has been that we do not decide models for our users. If users say that it has to go to GPT 4.0, 4.0, we send it to GPT 4.0, irrespective of which provider it is. Because it's before this we've been working for like 1.5 years on the evaluation platform, right? Picking a model is the extremely hard job. Anyone who comes to you and say that we do automatically pick up a really good model for you, they're faking it. It's not going to work. I can like put my name below that sentence that it's not going to work at all, because if it would have been easier, right now, just recently, if you see, Claude has started picking up models for you in Claude Code. That's not yet full-fledged feature, by the way. And OpenAI hasn't done it purely for the reason it's hard to do that in real time. Because it's technically another LLM call you're making and figuring out how complex the task is. It's just expensive. So
basically a bad configuration, your gateway can't do that.
You can't, exactly.
It's a combination of the provider and the model itself.
And the tasks that you're running,
yeah,
basically.
Exactly.
Yeah.
But if it's the nature of the workload is a very similar task and your request is coming in, but the load balancing modes themselves are like apples and oranges.
Absolutely. Exactly. We don't do that. Yeah. And we don't want to be there at all. Like, we don't pick up models for you. I have actually one slide, and then probably I can explain like quickly how load balancers works and everything. But technically, it's a gist that how we react to different things, how we flip the weights. But one thing that I wanted to actually tell you is that this is how we usually react. So I was talking about, as we are not proactive, we are reactive. Usually, and this could be like any baseline. Right now the baseline is basically error, but it could be any kind of baseline. It could be latency baseline, it could be error baseline. We try to go till the roof of it. We keep that straight line. We try to again break the roof, learn, again go back. So actually what we try to do, at least right now with the learning algorithm, is that we try to abuse every path that we have to an extent where we realize this is the limit of it. And that limit could be it starts giving higher latency after that, and the higher latency could be because it starts giving errors and we retry, or we start getting errors which are 4 to 9 errors or PTU excess errors, because after PTU, which are the provision token units, you are charged 3x. So essentially we try to figure out from the headers, we try to figure out from the status codes that, okay, this is the max limit of this path, and then we learn it. And this data is kept for like multiple buckets. So we keep that data for like a hour, 6 hours, 1 day, 2 days, 7 days, and then we learn from this. This is the max limit of it, and that's where we play. But we keep on breaking it. After every cooldown, which could be like an hour, we try to break it, figure out if there is something has changed on the configuration. If not, again we continue with that learning. That's what I had. But if anybody is interested, I can quickly go. Yeah, it's completely statistical. Yeah, nothing, no magic there. Yeah, no AI there. Only if else status. Yeah.
So how much latency it will add if we use this?
Yeah, we are the fastest one. So we actually add in microseconds. That's what we started with. So essentially, I actually have something else. Does it? So I'm not sure it's gonna show it or not. So our latency overhead is actually 11 to 20 microseconds, not more than that. That's where we play.
One last question. I was just looking in your repo. So you support, I guess, 23 plus at least on the open source. Can we add custom providers?
Yeah.
Yeah, we internally use Bifrost and use a lot of custom.
Yeah. Custom is support.
Yeah, we use a lot of open source.
Correct. Yeah.
How do you recover once your model is not because of the conflict? How do you recover? Say you have many requests bombarding your link, right? So do you buffer your request? How do you manage traffic situations?
Yeah. Okay. The question is basically how do we recover when there are a lot of requests coming in? It's a configuration, by the way. In the Bifrost, you can say that how do you want to handle excess requests. So we have a queuing and rejection. So you can define that these are the queued requests After that, we start rejecting.
Do you route your request to a single provider? Like when I say one word like OpenAI or and route it, so you route it in a single provider LLM or can we cross?
Can be cross, but that has to come from the client.
Client has to-
Yeah. We don't pick models for you. So if you give me GPT-4o and you configure OpenAI Open Router, we automatically know that both support GPT-4o. So we start flipping between them. Yeah.
Do we have some sort of gateway for MCP connections as well?
Yeah. It's a MCP gateway also.
So, do we handle different sorts of types of connections, SSEs?
Oh, we support three. We support three. We have SSE support. We have STDIO, and there's one more, right? The old one, which I think they're deprecating now. Yeah, HTTP. Yeah.
And what about the authentication and basically the
OAuth and header. We support OAuth, header, both.
Is it extensible? We want, let's say, particular filters for it. Maybe we want PII reduction there.
Oh yeah. So that's the guardrail part of it.
Plug and play.
Correct. So if you, so this is basically the guardrails that we have and the PI redactors we have. You connect your PI redactors, it runs on all the traffic out of the box. You folks use us, by the way. You're from Antical, right? Yeah. Bifrost is deployed in your, it's used as SDK, by the way.
So you might definitely explore other later providers like maybe port key or traffic or solo, right, or form, right? So where do they fail in terms of, and where is your differentiation?
One is the stack I talk about, right? You talked about Kong. Kong is, I think, JVM based. Portkey is JavaScript. In fact, are one of the competitors. I always show this repo. So yeah, so they actually decided now finally to move. No, more than that. I actually wanted to.
It's enterprise level.
More than that. What I wanted to show was like LLM Labs. What I wanted to majorly show was this. So that's the problem. You see Bifrost there, right? That's where we are good at. And this is fake. We've proven that, we have said them. But yeah, we are the fastest, yeah.
So maybe we were evaluating something like this. LLM was the thing, but it couldn't perform.
Yeah.
So we have a multi-modal pipeline.
Mm-hmm.
So can this be applied to the multi-modal pipeline?
Yeah, this is basically, we support all the models. We video, audio. Shutterstock is our customer, by the way. Publicly, we mentioned that. They are pure non-text. They are
We have a lot of
video.
engine
Yeah.
drawings and all those things.
Yeah.
To process that.
Yeah. So yeah, as I said, like the hardest customer for us non-text was Shutterstock. They are everything but text. So they have video, they have audio, they have image. We support all of them. Yeah. Cool. Any questions?
How do we provide observability?
We have connectors. We have built-in. So basically, we have this built-in dashboards where you see everything. On top of it, we have these connectors. So you can connect to any of these. Like if you want to connect to any hotel platform, if you want to connect to any BigQuery, Kafka, PubSub, all of that gets connected. Cool. I'm around. So if you have any questions, happy to answer them. But yeah, thank you so much, folks.
Cool. I think we'll have next shifter.